Well, welcome to this session of the Coffee Talk, the first one of the Discover 2017. And this is an Internet of Things session, and we'll talk about the refinery of the future. And I think most of you were here when I introduced myself as Gary Minchell. I'm the manufacturing guy in the room. And so we're going to learn about refinery of the future, some of the key topics you may want to be interested in, or I hope you are. Internet of Things, edge computing, are two key things, and then something we talk about in my area of the world called IIoT convergence. And OT, operation technology, for us is the engineers and IT staff that actually make the plants operate. And so the big topic forever in our field is that. We have Linda Salinas with us, plant manager, right?
That's right.
Yay!
You're doing a great job.
Doug Smith, CEO. Mark Schlander from HPE, and Manish Yeshwant from PTC. PTC is a partner of HPE and one of the key technology providers for this project. And I thought we'd just let Doug and Linda tell us a little bit about Texmark and why they decided to get into this refinery of the future. And the ground rules already been set. I'll get you a microphone around if you want to ask a question, and feel free to just let me know. So,
awesome. Okay, so thank you so very much for having us here at this first coffee talk of Discover Madrid. And I'm Douglas Smith. I'm the CEO of Texmark Chemicals. We're a specialty chemical processing facility located in Galena Park, Texas, which is just outside of Houston, Texas. Our primary product that we manufacture is called dicyclopentadiene, DCPD. We're about a 50-year-old company, and 3 years ago we did an analysis of the plant, what our strengths, what our weaknesses were, and we determined that one of the things that we needed was a new DCS system, which is a control system for the plant, and we needed to implement a mechanical integrity initiative. By determining those two needs of the plant, as a management team, we started talking with knowledgeable people in the technology field to assist us with those. That put us in touch with HPE. In our discussions with HPE, we learned about this new thing that I had never heard of called IoT, Internet of Things. And as an older company, we had never really embraced technology, and within this relationship, this journey of discovery, if you will, we looked at ways that we could employ HPE technology solutions to those two initiatives and then take it outside of those. So what we identified is a threefold path. One being installing a wireless network within the facility. Two was putting in compute power. So we put in the Edgeline 4000s and we put in an HPE micro data center. And so that served to form the technological foundation of this ROTF, this refinery of the future. Then we started looking at a five-prong approach utilizing different ecosystem partners. Our thinking from the get-go, our relationship from the get-go wasn't your typical client, person that's paying the bills type relationship. We worked together closely with HPE along the way to define what our needs were and move forward on that. Our five-point plan was, number one, to sensor different pieces of equipment within the facility and to do analytics on those specific pieces of equipment. Second thing was to do what is called, the connected worker, which would allow different workers in different positions to utilize technology to gain information from a piece of equipment. Another would be using video as a sensor, so we could use that for safety or monitoring, things like that. We put in another one for mechanical and asset integrity. And then the fourth and final one, Linda, safety and security, safety management, so we could identify location-based, be able to locate people within there. What makes this particular initiative, the Refinery of the Future initiative, unique is that we are working together to determine what our pathway is. We are working together with multiple ecosystem partners, and we're actually doing, not talking about it, we are doing it, and we have this foundation in place. We are working on these different solutions in phase 3, and we are moving forward. And with that, I'm going to pass it on to Linda Salinas. Go, Linda.
Thank you, Doug Smith.
You're welcome.
I'll key off of what Doug said as far as working together. 18 months ago, when we began our relationship with HPE and our management team working with their management team working together, the very next step for us was, in fact, to get our employees in on that process. And we have been working together with our employees. They really have been the key to guiding us down the path and establishing what our pain points are. They are the basis for how we decided what those 5 use cases would be. So 18 months ago, we spent an entire day. We had an innovation workshop with HPE and their facilitators. They spent the entire day with 20 of our employees, and we are a 50-employee shop. From our laboratory, our operations, maintenance, management, admin folks, the CFO was there, and it was a room similar to this, whiteboards everywhere, sticky notes everywhere, just getting engagement from the employees and saying, okay, what are your day-to-day issues? And, you know, they started big. Oh, well, there's never enough time, or we have too many meetings, or, you know, there's too many work orders, there's a backlog system, I don't know where to start. So it was that sort of big, lofty, pie-in-the-sky kind of stuff. But then they really drilled down to what is it really that are your pain points? And that is the basis for our 5 use cases. And this first one, the sensoring pumps, again, drilling down, the 2 pumps that we chose out of the 130 that we have in the plant are 2 of our most critical pumps. So one is our boiler feedwater pump. We have a single boiler, which is the single supply of steam to the plant, which is our single heat source to the plant. And this boiler feedwater pump is the only pump. So if it goes down, the entire plant goes down. So that has been censored with vibration, temperature, and pressure sensors. And that data is being transmitted wirelessly to the Edgeline 4000. The second pump that we chose was the vacuum pump for our DCPD, dicyclopentadiene process. So that is our #1 process train. It's the #1 product that we produce, and we are the #1 producer domestically in the U.S. And so we chose that vacuum pump because, again, it is a key, critical, crucial pump to the operation. So this is our opportunity to capture the data, to start getting some historical data, to start looking at the trends, to start building those computer models so that we can, in fact, predict, analyze, and hopefully prevent failures or make some sort of operational changes to those pumps and to those processes to minimize or eliminate failure so that we can then plan those outages accordingly. We've had enough unplanned outages before, and the outcomes are unfavorable. So you have a failed pump, yes, you're down, so that's bad right off the bat. But if you have a hydrocarbon release from the DCPD process, you have a potential for employee injury, you have a potential for a fire, you have environmental release. So all of those risks are then eliminated by that failure. So when you talk about where we got started with this concept of how are we going to improve our DCS and our mechanical integrity program. But then once we started talking to the employees, they said, yeah, we need to do that, but here's exactly what we need to do. And so that's probably the biggest piece of advice I would have for any company that's looking to start down this path of OT, IT, or IoT convergence is figure out where your problems are, and you're going to find that out from your people and see some real value there.
I just want to echo the people component, because the people in the organization, the people within HPE, the people within our ecosystem partners, the ability to sit down with a group and talk frankly and honestly and to assess when things work and don't work has been essential to getting where we are. The question that I'm often asked within my position is, well, Doug, how are you making money off this? Where is the money on this? And the money is in, when Linda gives the example of the pump, this is a very simple math equation here. Any wiring, a hard wiring of a pump within our facility is anywhere from $4,000 to $7,000 a pump, depending on its location. With this wireless network in place, any future pumps, that cost is eliminated. And then your mind can just run barefoot through the grass, thinking about ways, just in that one example. So I'm going to hand it over to Mark, our HPE ally.
So from an operations standpoint, we started with basically a very simple premise. We needed, to bring in some technology. So our first foundation was, let's build out the network. The second foundation was, let's take a look at making sure that we got compute technology to handle the use cases that you heard about earlier. So we didn't want to bring in individual pieces for individual use cases. We wanted to bring in one solution for the use cases they were running. As a result of doing that, we pulled in our micro data center technology, we pulled in our edgeline services, we also put in Aruba systems networks around about 10% of their facility. What's unique about Texmark is they have every piece of equipment a traditional refinery has. Their footprint is a lot smaller, just as complex but smaller. And so from that standpoint, it made it a great test bed for us to be able to bring in the technology, get it set up, work with the Texmark teams, and begin to really think through how we could deploy all of these use cases. So in a couple of the use cases, we've got those stood up and they're working now. We're beginning to bring data off the pumps, being able to see some of the savings that they had. They had initially said that, hey, we want to see 50% maintenance savings, and I think we came close to about 49% on the first run of what we've got for data right now. So we want to scale that out because the thought process is we can scale once we show this in a working minimum viable solution to across their plant. But those are the kinds of opportunities that we'll continue to identify. The second lesson that we got out of this was we started with, hey, we think we only need 2 or 3 vendors to help us with this solution. The reality is you need about 15 to 20. And they're either experts in electricity, they're experts in explosions, they're experts in moving things around in refineries. There's just a lot of different technology that has to be deployed to make these solutions work and to make them really take advantage of the OT-IT convergence. And that OT-IT convergence is happening, so we do see a lot of technology right now that either can be augmented or can be displaced depending on what the requirements are. And that's really kind of what we're focused on with Texmark. So we have a 5-year agreement with them to use this as both a test lab as also a place for us to showcase for not only our clients but other clients in the industry for what the art of the possible is, and they can use that as a test bed as well. So that's kind of what we've got going on with our friends at Texmark. I guess we'll just open it up to questions at this point.
Well, maybe we could let Manish talk about, we're moving a lot of data in all this, and I think that's one of the things that your company specializes in.
Yeah, that's right. I'm Manish Yashwant from PTC. So our product that we offer in the IoT space is called ThingWorks. And what we're doing with the Refinery of the Future project is HP brought us in as a partner in this arena. So what we focus on is application enablement. So if you think of IoT, it's a team sport, like Mark said. You need multiple vendors to come together to solve a problem, especially these 5 use cases that Texmark had identified. And we focus on really 5 things. One is sourcing the data, so bringing in data from greenfield or brownfield. So brownfield as in DCS systems and SCADA systems and so on, or greenfield as in sensors you add on to those pumps that Linda talked about through National Instruments, gateways and so on. The next thing we do is contextualize that data. So bringing in surrounding IT data about those pumps and so on. Third thing is analytics, so analyzing all the data that you've been harvesting. And then finally orchestrating, what the results of the analytics could be business decisions. So opening a service order or shutting down a pump or slowing down a flow, those kind of orchestration activities. And then finally, it's the human engagement. So in the form of applications, whether it's mobile apps or in the next generation AR and VR applications. Those are the capabilities we bring to bear with ThingWorks.
There's an amazing amount of data that comes out of manufacturing, and one of the debates in Internet of Things is where to do the computing. Do I move all the data into the cloud and do all my analytics up there somewhere? Do I deploy edge computing, and how much do I compute out on the edge, out by the device? Just curious, how did you tackle that problem, and where did you resolve it?
So what you bring up is what we face all the time in terms of where should compute take place. Let's take video analytics as an example. So on video analytics, you have multiple cameras on a facility. In some cases, it can be upwards of a couple of hundred. You don't want to take all the video that's coming off of all of those 100 or 200 cameras and bring it back to core. It's physically time-consuming. It also takes a lot of compute capability to actually, and network capability to actually make that happen in real time. So what you want to try and do is put video analytics at the edge, analyze what you're seeing through those cameras, and only send back the stuff that needs to be acted on back to core or back to a central location point for action. So what we try to do is, number one, understand the use cases. So for instance, the use case scenarios that would have to be acted on. For instance, a fire, an explosion, welding sparks, any kind of ignition source that might cause a disruption to the facility. Or it could be something as simple as an animal wandering on the property. Or it could be as simple as something falling, a ladder falling, or a human being falling. So in those particular cases, they each have a set of workflows that identify what they think has happened, and then that either gets brought back to core or it gets alerted to the leadership team immediately. So for instance, in some cases, if you've got a worker down scenario, what you want to know is where is that worker at, which location in the refinery are they apparently in at the moment, and how quickly can we get someone there to locate that particular individual. Particularly if it's going to be a fire or a smoke incident or something where there's a hazardous chemical on the ground that could potentially cause death. So what we try to do is understand exactly where that worker's at. That requires a lot of precision. So with the technology that's out there today, you can get within probably 15 meters of where the person is at, but if you use a mesh set of technologies, you can get to within half a meter. And we know how to get within half a meter on an XYZ scale, which is important in a refinery. If you've ever been in a refinery, you understand that there's ladders, there's scaffolding, there's a number of different locations that workers have to get to. And in some cases, they're either hanging off of a ladder, they're hanging off of a scaffold, or they're walking on a catwalk to get to the machine or to the area that they need to work in. And those are the things that we try to understand in terms of setting up the devices, setting up the digital image of the plant itself so that we can locate them both at a central location and at a remote location if need be.
So, Mark, that's interesting that you mentioned the video noticing an animal wandering on the plant. We have a coyote problem at Texmark, but the compute on the edge within the pathway, Texmark has proprietary processes, and it was essential from the get-go that we have the compute on site. So that was very important to us as a company. Anything to add, Linda Salinas?
No, Matt.
So,
Thanks, Gary. Maybe we could have a mic on both sides, I don't know, but this is good enough. Early on in your presentation, Doug, you talked about monitoring safety and security and being able to locate people at all time. I was kind of impressed with that. Are you locating them by station, or are you locating them by some kind of badge, or do you have some RFID tag in them, or how do you keep track of people?
So in Las Vegas Discover, we talked about swim lanes in one of the interviews that I did. What we have determined in this relationship with HPE is we work together. Texmark focuses on the chemical processing, what we're doing, and HPE advises with the technology aspect of things, and then we work together to come up with the solution. So I'm going to pass this over to Mark to talk a little bit more about that.
Sure. So in order to locate a human being, the very first thing you need to do is make sure that the human being is wearing something that can be tracked. It can be a wearable, it can be a hard hat, it can be something that's embedded in a vest, it can be embedded in their shoe, it can be something that they carry with them. The problem with something that they carry with them is it can be dropped. So typically what we try to focus on is something that's required by OSHA. So if you go into refineries, you're required to wear a hard hat. So what we do is we embed technology in that hard hat, and that hard hat has the ability to monitor biometric data, location data. It has wireless technology to communicate and provide video both on scene and collaborate with workers within the area or around the plant. So for instance, they're looking for a particular human being, they can say, hey Joe, where are you at? Joe can respond back. They can create a instantaneous network just communicating amongst themselves. Typically most workers will roll in with a radio. They'll roll in with a number of different wearables. They've got gas sensing devices, all sorts of things pinned to them. What we would like to do is get that into one form factor and then have them use that form factor repeatedly. So we have the technology to do that. That's what we'll be demonstrating at Texmark, but we also have, we've entered into a number of agreements with a couple of OEM opportunities as well. Okay.
Any other questions?
Getting your exercise. Yeah, gotta get you 10,000 steps.
That's right. Yeah.
So, you started the process with a consultation with staff. How did that turn around as a closure of the loop? Was there a lot then of education of staff as the systems were implemented? Were there changes in how the staff work and what their interactions were?
Absolutely. And it's a continual education with the staff and with HPE because we are learning about the technologies and the capabilities. But it's because we included the employees at the very beginning that they and we have continued to better understand what the technology can do for us. So that has been exciting. The other thing is that over the 18 months, as we sit in our day-to-day meetings, whether it's just a daily planning meeting, it could be a new project, something that we're looking at for the next 2 to 5 years, it could be troubleshooting, it could be an incident investigation, anything. I find that now as we sit in these meetings that I'll hear back from the employees that IoT or the Refinery of the Future, or we'll call it ROTF, as we're sitting around the table trying to think of solutions, I'll hear them say, well, how can we use ROTF? As if it's a thing, how do we use the ROTF to help us in this situation? Either make this new project that we're looking at more efficient, or how can we do it quicker? Or if we had an incident, how could ROTF have helped prevent this? When we talk about the connected worker and the hard hat and knowing, worker down situation, it's good to know where they are so that you can get to them and render first aid. It's also good to know where there is an emergency in the plant so you can direct employees away from that. So imagine a scenario where you have enough weather data or hydrocarbon sensor data in the plant, and then we have our automatic emergency alarm system. So if we know where all 50 employees are in the plant, and we have the wireless mesh network, so we know where all the sensors are, and then we identify that there's a hydrocarbon release, say at our rail car loading area, and we know we have a prevailing southeast wind, then when the sensor detects that there's hydrocarbons and a potential for fire and the wind direction, and that there are, in addition to that, another 50 contractors working in that area, then the alarm will sound, and it is then immediately followed by a message that says, you know, there's a release in the rail car area. There is, you should shelter in place, so stay in your building, or you should go to a rally point, and which rally point to go to based on the incident. We also have an emergency response team and firefighters as well. So we want to be able to direct them to where they need to go, what they can strategize, how they will attack that situation, and then we'll also, part of the response typically is to look through every building, look through every process unit to make sure that everyone has been cleared and is safe. Well, if we can identify that everyone is already safe, then we don't have to send the rescue crew in to even look for them. We can instead just focus on the emergency or the incident itself.
Okay. Just listening to you, I assume you have the technology to shut the valve down to stop it if you detect the leaks.
In some cases we do, but this plant has been there since the 1940s. So there are a lot of manually operated valves. And I'll tell you, even in the newer facilities, a facility that was built last year or in the last 10 years, not everything is automated. You can't just hit a button for everything and shut it down. So some things do require manual intervention to go in and close a valve. There are definitely some remote shutdown capabilities, but not everywhere.
Ouch. Okay.
She said I was excited about something. I'm excited because what this project, this Refinery of the Future project, and I'm glad PTC is here because we have been working with these ecosystem partners, and the relationships with our ecosystem partners are essential to being successful. The point that I was driving at was education, education, education. So assumptions are made in the world like, oh, what, plants? Shouldn't you be able to just flick a switch and everything will be just fine? No, it isn't. It doesn't matter if it's the newest plant on planet Earth. There are going to be manual valves that you have to shut off. Things go wrong in the world. And in a petrochem facility, we're operating in a dangerous, hot environment. And we are doing it. And that is one of the things that really makes what we are doing at ROTF at Texmark Chemicals just unique in the world. Is we're inviting people to come see the technology and see it being actually used.
I was going to say, everybody I've talked to over the last several years on Internet of Things leads with predictive maintenance. And you talked a little bit about predictive maintenance, but you focus on safety, which is way cool. And we have a question over here I'll get to. But Manish, you had...
Yeah, I mean, I was going to say, yeah, predictive maintenance is certainly the initial step. You know, it's a natural migration from condition-based maintenance to predictive maintenance. Today, most customers have a condition-based maintenance system in place. You know, you see your check engine light go on in your car, you know what to do. You take it to your service station. But can you predict when it's going to fail and control the parameters of your pumps and equipment so you can get a little bit more time before you can shut down your process and take the corrective action? So that's the kind of the nirvana that most customers are going after.
I got three questions. I'm a bit curious how you guys are using AR. I think I've seen the pumps what PTC have done with that and how you're visualizing, right? But are you looking at head-mounted display? Because there's tons of vendors out there. Then you're removing the hands-free, right? Which makes it more safe, which is critical in your operation. How far is that something you are evaluating?
Yeah, actually we are. So I talked a little bit earlier about location-based safety for workers and stuff. What we're going to do is integrate the technology into the helmet. So there's a couple of companies that we work with, particularly around augmented reality. So the ideal scenario would be the worker walks up to the pump identifies the area that the worker needs to take a look at. If it's a particular sensor, the sensor can say, hey, I'm failing. They can then bring up a manual. They can figure out what the failure is. They can figure out the failure code. They can either bring the appropriate equipment with them and replace that sensor or get somebody called in that can actually adjust the sensor.
I work with augmented reality.
Yeah.
That's why I'm a bit curious. Which one are you working with? Are you working with ODG? DAC?
No, actually, right now we have a technology inside HPE called virtual remote guidance.
Okay.
So we use that along with off-the-shelf technologies. So we're working with companies like Realtek and GuardHat, those types of companies.
So HP is building their own.
We already have. We've had VRG for over 15 years.
Okay.
So it started with our printer company. So what we used to do is we send printer techs out to fix these large printers. In some cases, they didn't have the technology training, but they could rely on somebody that was a subject matter expert back, in another location, particularly in some cases in another country, because they were a very specific printer that only one or two people had subject matter expertise in. And rather than flying them in to repair the printer, we would just...
But I just know it's very difficult to make a device that is validated on explosive areas, right? Which what?
Yeah, Class 1, Div 1. So, yeah, these helmets I was telling you about, they're all Class 1, Div 1 rated helmets.
Okay.
So...
The second question was, are you guys doing anything with robotics? So artificial intelligence, more like, I guess, automating some of the human process. Now you got all this data, right?
Not yet. Not yet.
Okay.
Not yet. The first 5 use cases that we came up with were designed to really address some of the major business issues that they were looking at. As far as robotics, I think what they'll probably potentially end up doing will be using robotics with cameras and stuff to go inspect certain areas and stuff.
Okay, so the camera stuff, what you're doing, because I know you're doing the Edgeline EL4000. Is that with the M710X, or are you doing anything with NVIDIA? Because I know some of the reference architecture you're showing here, Discover, are you talking about where you identify the different objects on the video analytics?
Yeah, you can have it identify either certain scenarios or certain objects and stuff. So from that standpoint, the idea right now is with what we're doing right now, we take the PTC digital twin. We have the ability to basically take a look at a pump, and then we can have it, we can have that pump indicate which part of the pump the tech needs to work on. Okay. So from that standpoint, that's kind of as far as we've gotten right now.
Okay.
Okay.
Yeah.
All right.
You brought this up a few minutes ago on partners and ecosystems and so on. I was curious about what was your process? Why did you pick HPE anyway, and how did PTC get in the mix? And pump companies like Flowserve that enable their pumps and so on. So how did you wind up with them?
Sure, but I want to go back to this question that you were asking earlier, sir, regarding the video technology and the hard hats and things of that nature. I really appreciate that question, because I get those questions about, well, are you doing this, or have you considered this, or I'm in this field. What we Texmark have done in terms of defining this project is we built this foundation, the technology foundation, and now we have these 5 use cases. And what we are doing is we are systematically proving these 5 use cases, and we are constantly asked questions. Well, haven't you heard about this newest technology? It's doing this, that, and the other. And what I tell my team is we have to focus on proving either the success or failure of these 5. And we may prove success in 3 of the 5. But once we do that, then we can start saying, oh yeah, okay, the technology is advancing along the way. There are so many cool things out there, and it's really, I'm a ADD, look at the shiny object kind of guy, and when I hear things like that, I'm focused on it, and I need people like Linda and our technical team to go, Doug, focus on this, and then I have to preach that message, because there are so many technologies that are out there. So I'll hand it to Linda now.
And regarding the augmented reality and the heads-up display and the hard hat that Mark was talking about, that does tie in with our connected worker and context-based use case. And one of the things that would be where it would apply to us, and the things that we're doing today versus how that would help us in the future, is traditionally you might identify a problem in on the control room. You've got 16 monitors that's monitoring all of our processes, all of our distillation towers, and things that are flowing from point A to point B. When an alert goes off, and you see that there's maybe you lost flow or your pressure is dropping and it should be higher, the control board operator will send the outside operator to go outside and check this. Oh, go see what the problem is. I think we lost flow in the feed train. So the control board guy is watching the board. The operator goes out to the plant. He's got his two-way radio. He walks out there. He goes, oh, well, the local gauge says that everything is fine. What do you see in the control room? Then the guy in the control room will say, well, I'm still losing pressure. Why don't you try opening this valve a little bit? So then the guy comes back on his two-way radio and he opens the valve a little bit. And then the guy in the control room sees a change. He goes, okay, that's better. The pressure is improving. So maybe the local gauge is not working, but they're having to do this communication, this two-way radio communication, what he's seeing on the control screen and then what they're seeing in the field. Imagine if they could have this heads-up display, the hard hat in the connected worker use case, and he takes the control board or that screen with him to the plant. So now he goes out there and he's doing all the troubleshooting himself real time. So he sees the heads-up display, his hands are free. He knows what the situation is. He knows how to troubleshoot it. He'll go out there and open that valve manually and see immediately in his heads-up display that it's having a positive impact on that situation or on that alarm that triggered the response to begin with. But not only that, but he could also see the impact that it's having either upstream or downstream of that process. So not just that one pressure sensor that was going up or down or in the direction he didn't want it to go, but how it's going to impact the whole process. You could show how it's going to impact your production rate. It could show how it's going to impact quality. Did we go off spec for just a moment? All of that is right there in his heads-up display. But as Doug said, that's in our use case 3 or 4 down the road, and right now we're still on 1.
So when you're saying all this, my brain is just saying, why not do that with drones? With drones, right?
Because we have our 5 use cases.
Yeah, okay. Fair enough.
Yeah, I just want to add to that, to a point that Linda's making. We are heavily investing in augmented reality as that next generation human-machine interface, because today technology is delivering those dashboards on mobile applications and desktop applications. But we want to provide the data in context of where you are and then what machine or asset you're looking at. So that's really the next generation value add. So that looking at the real asset and projecting the right digital information to augment reality is going to be the next wave. I think we can go to another question. Okay.
Alistair, competing mics. I think, Doug, the question that I have in my mind when you talk about AAD, and nearly everybody here suffers from AAD, otherwise we wouldn't be doing some of this stuff. But where did you get that jacket? And is that a source of your problems?
So the source of all things good, the World Wide Web, provided this. But back to, go ahead.
Okay, I wanted to quickly answer the drone question. Drones are great, and they are being used in the inspection industry, especially if you need to take a look at a tower that's 100 feet in the air. But imagine you see these trusses going across these support beams. This is a lot like how the plant is. So you've got pipe racks, you've got conduit, you've got equipment and so forth. So the drones can hover, that 30,000-foot view, but to come in and down and look at that pump or that scenario that I was describing, you'd have all these obstructions, and so it just wouldn't be practical in our congested sort of area. Now, if you had something remote, like a tank farm way out there, and you wanted to save the guy some steps, and you could just kind of generally get an aerial view, that's fine, but you usually need to get up close and personal with the equipment.
Well, and then also, we're in a no-fly zone. We're near the Houston Ship Channel, and it's homeland security. What was your question again? I'm sorry, I got off track.
Oh, that was a good track, though. There are some really cool AR applications coming, and I think Manish talked about it. Yeah, so what I wanted to circle around back to was, why did you pick HPE in the first place? What was your criteria for picking a technology partner or partners?
Sure, and it goes back again to people. At Texmark, we put a great emphasis on on our team, getting feedback from the team, initial conversations. When we determined the DCS need and the mechanical integrity need as a management team, we started using our contacts to start talking about, hey, we need some technological expertise. We started conversations with HPE, and then it stepped into the whole IoT arena. HPE has this IoT lab, or had an IoT lab down in Houston, Texas, and went there and saw they had this sensored pump. And it was I said, well, where are y'all doing this in the field? And they said, well, nowhere yet. And so I said, well, we have just a few pumps. You want to come do it with us? And that was the first domino that fell. But then it's just, you know, working with the team, being able to bring our people into the conversation, be able to bring these ecosystem partners in.
What do you recommend? Yeah, I think what Doug characterizes is pretty true. It started out as just a simple conversation around art of the possible, and can we try this? And we found a willing partner that was willing to collaborate with us, and that's when we started to open up the discussions to much more than just a pump. It was, hey, there's a transformation here that you can demonstrate for the rest of the world. Are you interested in doing that? And that's when they came up with the arrangements that we have now with them. Okay.
Okay. Any other questions? Did you want to know what website he went to get the coat, or?
Loudmouth Golf. I'm making a pitch for loudmouthgolf.com. No, seriously, this is a very exciting topic, and I just can't say it again. People, 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 and then also having the guts to say, let us try it. My association with HPE, so we've been working on this project for 18 months plus now with the ecosystem partners, with HPE. They have, I said from the get-go, I, as a representative of and owner of Texmark, am committed to this. We can transform this industry in so many other industries. It gets me so excited about things. So we have a process facility. I think about shipping and how we're over here in Madrid, and how our products, we buy feedstock from Asia and it comes across on ships, and all ships are a big old plant on the water with boilers and pumps and piping. So everything that we're doing in terms of our IoT solution can be applied to shipping. It can be applied to hospitals. It can be applied to education. My passion is education. Within our industry, I said it's hot, dirty, and dangerous. We're losing workers that are retiring out with all this intellectual capital, and young people don't want to work in a dangerous, dirty, and hot environment unless you have something cool that they can tag in on their cell phone. Here, you talk.
Yeah. Thank you, Doug Smith. He's absolutely right. And this is this IoT Refinery of the Future project really ties in very well with another challenge that we have in the industry, and that is the generation of workers that is nearing retirement. They have all of this tribal knowledge about the plant, and when you talk about, well, can't you just hit a button and shut something down? Well, in some cases we can, but in other cases where we cannot, we have these workers that have been with us for 20 or 30 years that when they see an alarm go off in the control room, they know exactly what the problem is. It might be some age-old problem. Oh, they've never fixed that. Go over there with a hammer and beat it on the side and it'll be fine. These guys know the tricks. They can walk through the plant. They can see it, hear it, smell it, and they know exactly what changes need to be made, and they are our sensors right now. But then we've got these younger workers coming straight out of process technology school, and they want to be able to run the plant with this or with their heads-up display. And so this Refinery of the Future project, this IoT-OT convergence project, has brought those two generations together. So we've got 20-somethings and 50, 60-somethings in the same room trying to make this IoT-OT convergence project work. We're getting all that tribal knowledge and we're getting it into these computer models. We're training the younger folks, and everyone is learning across the board. And then that just builds sustainability for Texmark so that we can continue to operate for another 50 years.
So we talked about this as being an IoT, where the I is internet, but as far as I can make out, your data model is entirely on-premises, retaining the data. You've got a lot of intellectual property. How much use of actual internet services is there in this solution, or is it an entirely on-premises solution?
Right now it's completely on-prem. So the thought process is that with the micro data center that they have, they can create and use all of the data models within that micro data center. With the edge line devices, they can keep it at the edge if they need to, and then bring it back to that micro data center. So it keeps it very secure for them, and it's a requirement. In a lot of those industries, what you'll find is there's a bias towards leaving it on-prem, and in some cases, it'll never see a cloud, but it can see a cloud-like model that's on-prem. So
I'm really interested in Manish's point of view on this one too.
Yeah, I think what you're going to see as you scale out the solution beyond one plant to multiple plants, multiple sites, and so on, then you'll start to see these hybrid architectures where a bulk of the solution is on-prem, you're harvesting data, you're analyzing at the edge and serving up applications at the edge. But then you want to compare operations from one plant to plant or shift to shift. Those are the cases when you'll see some key KPIs being aggregated in the cloud across all these plants. Also, when you start to leverage interesting web services like notification and so on, those are the things that you will leverage web applications as well.
So, Linda, you brought a good point about this new generations that are coming. They all want to do everything on their phones. How do you see that playing out into the future vision of the refinery of the future, 10, 15, 20 years ahead, like way into the future?
That's a long time. I can tell you on that the use case, the connected worker and the heads-up display. Again, this is not just Doug and me working with HPE to figure all the solutions. On use case 4, we have one of our newest employees and our youngest employee, Daniel, working with the team. And we are asking him what his vision is for the next 20 years or so. And so it's been him and an engineer and a facilitator, and we sit around the room. And I just bring him to the table and sit back and ask him enough prompting questions like you just did for him to get some ideas. Oh, yeah, I thought this would be really cool. And he talked about drones as well. And he talked about being able to see the entire plant. The thing that I just described to you was not my idea. It was Daniel's idea. He's like, this is what would be really cool to be able to do.
So one Daniel story, our poster child for new technology into the future, Linda had mentioned our emergency response team, our ERT team. Texmark is absolutely committed to safety. We do numerous trainings throughout the year. We just finished a plant-wide training with the emergency response team and the EOC team, which is the Emergency Operation Command. At the end of the exercise, which we do at the Houston Fire Department, we do a debrief. And here's the story: is everybody gives their little debrief, and so you see all these older people pulling out their notepads and reading what they did in the meeting. Daniel's at this meeting. Daniel whips out his phone, starts one-handed thumbing and reading everything that he's doing. And I sat there and I just shook my head and I go, this is the future. This is, once again, dominoes. That's the first domino. And
okay, here's another one of Daniel's ideas for, not even 20 years down the road, but in a couple of years, is that we have a 3D digital twin, a 3D scan of the entire plant. And so we have that now. So we've used that for modeling, for construction, and we use it to capture our mechanical integrity data. But he said, well, what if rather than doing the emergency response team training in the field, in your gear, for the first time, instead use that augmented reality or virtual reality, I don't really know the difference, but anyway, using that with the 3D model to provide emergency response training or operator training so that you are virtually walking through the plant for the first time so that you're not exposed to the hazards of the plant on your first day on the job. So you can walk through with your trainer. Here's the valve. Here's how you start up the pump. This is how you shut it down. This is how you clean it out. If there's a fire here, you'll come from upwind and you'll attack it this way. All of that training can be done in a safe environment without even going out there.
Texas in the
Yeah,
summertime.
and cooler.
So what she's saying, Houston, Texas is like Singapore or Angola in terms of temperature and safety gear. I mean, to be able to do it in the air-conditioned comfort of the virtual world, shoot, yeah.
Simulate emergencies.
It sounds really amazing what you guys are doing. I'm actually quite inspired by it. Are you showcasing what you're doing with VR here? Because I know you can 3D print a device, and then that's what a lot of companies are doing. Then they're actually simulating for education-wise, which is, I guess, more powerful than AR. Education-wise, I think VR is really great. That's why I like you both using both technologies. Can you share what you're doing with VR?
That would definitely be a future phase. And
okay.
just talk. This is Doug talking here. I haven't talked to Mark or Linda about this, but yeah. Going off script here, but. The possibilities are limitless. Yeah. With this 3D scan, this 3D model of the plant with data embedded in that model, there are so many educational opportunities, and this goes back to pie in the sky dreams, and economics play a great deal in this whole equation. If we saw a return on doing something, Texmark would bankroll that. But if somebody wanted to come to us and say, hey, we know you're doing these things, we want to put a bunch of money in it, well, yeah, we'd consider it. Yeah, we'll talk about it.
Thanks.
You're welcome.
Thank you very much. I don't want to cut off any discussion, but I think our time is about up. Correct, boss?
Well, thank you. I really appreciate it. This is super exciting territory that we're walking into. IoT, it's a great opportunity to collaborate with all the ecosystem partners, HPE, and to tell the story and get the story out there and get people excited about it, the younger generation, and come see us in Galena Park, Texas.
Thank you very much. This is as good an IoT use case as I've seen. Congratulations. As well.